Hi everybody, my name is Nabin Chapagain and I'm going to be presenting my poster for computational geometry insights into Monte-Carlo simulation methods today. It's a computational physics problem that I've been working on with Dr. Amir Samuradi, and mm, so the problem is to develop a, an autonomous algorithm that that gives us the number of clusters and the information about the clusters for the multidimensional data set that is passed into the algorithm. And we're trying to develop a self-sufficient algorithm um, that is faster and computationally cheaper than other algorithms that are available in market right now. So as I said earlier, this algorithm works on multidimensional data set, and just an example, there's this picture over here. As you can see at the top, the blue dots are three-dimensional data points, and the green points, they signify the minimum volume bounding ellipsoids. And um, after passing that data set through the algorithm, it divides them into three small clusters, and the red points that you see over there are the minimum volume bounding ellipsoids for each of those three clusters. So that's an example of the algorithm at work. And so how does it work, right? So what it's fairly simple. So what we do is we divide the data set into smaller chunks. We divide it into uh, uh, two subsets and then divide those subsets into further smaller chunks and keep on doing so until a certain criteria is met. And the criteria is mentioned under the section of how does the algorithm work. So you can read it up if you want to. And mm, let me just quickly go over this. So the picture at the left, you can see there are green ellipsoids. So those are the parent ellipsoids from which we are sampling our test data from. And on the right, you can see the points. Those are the sample test data, right? So as you can see in the left, there are 10 uh, parent ellipsoids. So uh, it is when we pass those data through the algorithm, um, we are supposed to get those 10 clusters. As you can see, those points were actually sampled from those 10 clusters. But what the algorithm does is it gives us 19 clusters, right? And it's not bad because in an ideal condition, we would get 10 points. But since these are the sample points and there are so many other points that are available in those ellipsoids, it's a um, it's a good thing to have 19 clusters. And as you can see over here, there's not much waste also. Uh, but something available in market right now, a well-established package called Dynasty Package. I'm using that package to compare the workings of our algorithm. So as you can see over here, this is Dynasty Package at work, and you can see there is so much waste over there. But something Dynasty Package does really well, and my algorithm is struggling with, is to account for those points that are not in the sample data set provided. So the next step for me would be to work on that and improve my code such that it could account for future data set as well, or the data that can be sampled from the parent ellipsoid. And I would like to end my presentation by saying that this is a project that will be beneficial for different fields like psychology, finances, and so on. And I hope our work will be beneficial for everybody someday. Thank you.